Uh, Hello again. Here is notes 8.02 on trigonometry. A lot of you were doing very well with finding a side. And let me review a quick second. Now you don't have this warm up, but I just want you to remember the process here. So SOHCAHTOA is our acronym. It's used to find sides or angles of right triangles. So I have a problem started here, letter A. Set up a trig function to find side x. Solve and round to the nearest tenth. Remember, you're going to need your graphing calculator, so if you don't have that, pause the video and grab one. But from our angle, we always identify our opposite side, our adjacent side. There's nothing next to our hypotenuse here, so we're going to not use sine or cosine function, because again, we don't have the hypotenuse. So this is going to be the tangent. Angle 32 goes in, equals the opposite side x over the adjacent side 13. In order to calculate, we cross multiply. Tan 32 gets multiplied by 13 equals x. And onto the calculator. Let me double check them in the right mode. 13 tan 32. It's going to give us that this measure of x is approximately 8.1 rounded to the nearest tenth, which again is the measure of the side BC here. Setting up another trig function for letter B, or I'm sorry, letter C here. If you want to pause the video and try it on your own and then check back, I'm going to start from the 37 degrees. We have two sides, the hypotenuse, adjacent. So adjacent hypotenuse is going to be cosine over angle 37 equals 11 over x. Now when we cross multiply here, we got to be careful because now x is in the denominator. We're going to end up dividing. That's a little hint when you're setting these trig functions up. So when I cross multiply, we get x times cos 37 equals 11. Now x isn't alone yet. We have to divide both sides by cosine 37. And into the calculator, I'm going to type in 11 divided by cos 37. And here we get approximately 13.77 is going to round for us to 13.8. Again, that's finding lengths of sides. So here, x was a side measure, 13.8. In the first picture, x was the opposite side. Our notes for today, we're going to be talking about finding the angle measure. So in the first example, we're finding an angle, looking at note 802. It says set up a trig equation to find the angle of elevation x. So this plane is flying. If you think of the ground here, it's gone 400 let's say meters out. The altitude of that plane is 300 meters, maybe above some point on the ground underneath it. So that's a height perpendicular. And they're asking us for the measure of this angle here. So the two sides we have compared to this angle, again, are the opposite side, which is the flying altitude of the plane, and we have the adjacent side. So opposite adjacent is going to be tangent. So remember, next to our trig function always goes the angle, and that's what we're going to be solving for today, is angle x equals the opposite 300 over the adjacent 400. Now this is a new process to go into the calculator. Okay? So when you have to find an angle, you have to use second. So we're going to use second button, then we're going to press tan. And what that brings up is tan to to the negative 1, or if we press second cosine, cosine to the negative 1. So it's essentially trying to divide this tan out so x can stand alone. So how we're going to write it is we just jump to the next line. We'll say x equals tan to the negative 1 of 300 divided by 400. So I'll show you in the calculator how that works. We'll clear out our line. And again, we had our second button first, tangent. And you can kind of notice in blue above your tan button, it says to the negative 1 of 300 divided by 400. And hit enter. And that measure there is now going to be an angle. So the angle here, and it does ask us to round to the nearest hundredth, so I just had to double check. X is approximately 36.87 degrees. Again, that's 6 over here in our calculator does round up to a 7 for the hundredths place. So that angle measure, again, going back to our diagram, is now about 37 degrees up, which kind of makes sense in our picture. It's definitely smaller than 90, and that's an acute angle. So this second tan idea, or second cosine, second sine, is again used whenever we need to find an angle. So moving down to exercise 1, find the measured angle x to the nearest tenth of a degree. So looking from angle x, we need to find the opposite side. 17 is our hypotenuse. So our trig function is sine. Remember, next to our trig function goes our angle x equals the opposite 9 over 17. So this is almost a little hint. When you have both parts of this ratio here, the numerator and denominator, that's when you need to go to your second function, the sine to the negative 1. So next line, we're automatically going to write x equals sin negative 1, 9 divided by 17. And into the calculator, second sine, 9 divided by 17 is going to give us approximately 31.9. I'm going to write this out. 31.965. Now reminder, this is our tenths place where the 9 is located. The 6 is telling us to round that up. So this answer is actually going to round up to 32.0 degrees. So remember, we do need to keep a number in that tenths place to show that we rounded there. For the next example, B, I got a B. Okay, we're trying to find the measure of an angle. We start to identify our opposite adjacent hypotenuse. So the opposite side is 34, our adjacent side is 39. Opposite adjacent, so tangent of angle x equals opposite 34 over 39. And we automatically go to the next line. So again, when we're finding the angle, when x is over here next to our trig function, we start by writing tan to the negative 1 of 34 over 39. And to the calculator, second tan 34 over 39 is going to give us about 41.08. So x will round to 31.1. So that's exercise 1. Okay, exercise 2, if you'd like to pause the video, try it on your phone and come back. I would suggest doing that. Looking at exercise 2, we have angle x. Here's our adjacent side touching the angle, and across from the right angle is our hypotenuse. So we're going to use cosine of angle x equals 7 to the adjacent over the hypotenuse 16. X equals close to the negative 1, 7 over 16. Okay, we got 64 degrees. So again, we're rounding to the nearest degree. So x is approximately 64 degrees. And just looking at that diagram a second, that angle does appear to be larger than some of the other ones we've done. So 64 degrees is still less than 90, so we're doing good. Exercise B. Angle X is up top here, and we have two sides. So now we have, from angle X, we have its opposite side, and from the right angle, we have its hypotenuse. So opposite hypotenuse, we're missing the adjacent. So some of you might prefer to label the adjacent every time. Maybe that's an easier way to find the adjacent and the hypotenuse. The leftover piece would be your opposite. So here we have sine of angle X equals the opposite 51 over hypotenuse 54. Into the calculator, second sine 51 over 54. It's going to give us approximately 70.8. We'll round to 71 degrees. So hopefully we liked finding the angle. Looking at some word problems on the next page. Here, the diagrams are kind of given to us. You'll find some questions on your homework where you might need to draw your own pictures. But Ron and Francine are building a ramp for performing skate stunts, as shown in the accompanying diagram. The ramp is 7 feet long, so here imagine a skate ramp, and it's 3 feet high off the ground. What is the measure of angle F the ramp makes with the ground to the nearest tenth of a degree? So again, we're finding the angle X. We have the opposite side, which is our height. We have the ramp measure, which is 7. Opposite, and the ramp is really our hypotenuse here. That's just what I wanted to write. So opposite hypotenuse is sine. And X is 3 to 7. So therefore, X equals sin 1, 3 over 7. Sine 3 equals. So there's about to the nearest 20 degree. X is approximately 25.4 degrees. So the one near 3 there is going to round up because of the 7 4. Okay, exercise 4. So the pole of a tent appears to be 8 feet tall. The side of the tent is 12 feet long, as shown in the accompanying picture. The right angle is formed where the center of the pole meets the ground, and the measure what is the measure of angle A? It's in nearest degree, so we're finding the angle measure here. So from here we have the opposite side and the hypotenuse. So sine function is opposite over hypotenuse. So we have sine of angle x equals 8 to 12. X will be approximately, not these answers right now, 41.81 is going to round to 41 degrees. Oops, mistake. Try this again. Not 41 degrees, Miss Bell. It's going to be 42. The 8 will bump it up. So that angle here is going to be 42 degrees. We could go about finding other angles. We could find this one here would be its complement. So we have 90 degrees. So if we took 90 minus 42, we would get 48 degrees. So just remember we have some complementary angles. That's going to come up in a few lessons from next week. Last but not least, exercise 5, to build a handicap ramp. Building code states that for every 1 inch of vertical rise, the ramp must extend 12 inches horizontally. across. Remember, horizontal goes left to right. Vertical goes up and down. So the 1 is representing 1 inch is opposite, and 12 inches. So remember, in the future, we're going to have units, especially coming up in our volume topic. These units, inches and inches, we want to make sure are always the same. So 1 inch high and across 12 inches is representing our adjacent side to this angle X. So here we're going to find to the nearest hundredth of a degree. So opposite adjacent is tangent, X equals 112. So X equals 10 to the negative 1 is 1 divided by 12, which is approximately 4.76 degrees. So those are the notes for today. Went relatively quick. Now, make sure you understand your homework tonight. So we're going to skip over this classwork for now. But here we have homework 8.02, kind of starts with a diagram. So I'm going to read a couple of these just to help you label your diagrams, but you will not always be finding the measure and angle for these questions. So looking at like 3 through 5, that's finding sides. So if you need help, look back to notes 801. But here you're finding a side, so you're not going to use the sin to the negative 1 here. That's not what we're doing in this case for 3 through 5. But reading back up to number 1, if I help you label the diagram. From the hayloft door, Ted sees his dog on the ground. The angle of depression from Ted to his dog is 40 degrees. So our next lesson is going to talk more about these application problems. But from Ted here at the barn loft door, he's looking down at 40 degrees. So what that means is we have the sight line coming out is always parallel to the ground. So we're going to have that alternate interior angle being formed. So the 40 degrees is going to bump down here as well. Now, another little idea that some of you might see is if it's 40 degrees here, then it must be 50 degrees right there, so that we have this right triangle, and all three angles continue to add to 180 degrees. So the other measurements, Ted's eye level is 16 feet above the ground. That means he's up 16 feet to that barn door. And the question reads, how many feet must a dog walk to reach the barn door directly below Ted? So we're trying to find a measurement down here. So again, that's a side length. So setting up our trig function, the parts from this 40 degree angle that we have, so if I focus on 40, we have the opposite side and the adjacent side. We did not know the hypotenuse, so the adjacent is tangent. This is where angle 40 goes, equals the opposite side 16 to our adjacent side x. Now, had we focused on the 50 degrees, this would have kind of flip-flopped around a little. But from here, when you cross multiply, make sure you put your tan 40 over 1. So we have x tan 40 equals 16. And to solve, you're going to divide over. Okay. So I hope that kind of gets you started. Now, number 2, we are solving for an angle. And it looks again like the tangent function. You have your opposite adjacent. So this is where you will need the tan to the negative 1 of your opposite adjacent. So if those couple clues help, I can't wait to see what we're doing. Thank you so much.